Hello everyone, welcome to this video. In this video, we shall be looking at another question, some problems based on calculating the sum of n given sequence, which is an arithmetic progression and AP, correct? So the question here is, if we are given the sum of first n terms of an AP, which is given to be n into p plus 1 by 2 n minus 1 times q, right, where p and q are given to be constant. So we need not worry about p, we need not worry about q because they are constants and we can assume that they are given to us. So the only term that is variable is n here. So the sum up to n terms is given to us. So we need to find the common difference here. So that means in order to find the common difference, actually we need to calculate the terms of this AP. And in order to evaluate the terms of an AP, what do you require? You require the first term and the common difference. Actually, the common difference would be calculated using the term. So we have to use the formula for sum because that is the only thing that is available to us, right? So this is the catch here. So here, if we assume first of all that a1, a2 up to an represents our AP, right? This is the notation. Then the sum up to n terms, so that means when we add all of them, a1 plus a2 plus a3 and so on up to an, so we would have this as equal to Sn. And what is the formula for Sn? The formula for Sn is n by 2 2a plus n minus 1d, correct? This is the formula, and in question this sum is given to be this one, np plus 1 by 2 n minus 1 times q, correct? So here, if in this expression, if you have n is equal to 1, so that means what is this thing? This thing is equal to Sn. Now if you have s is equal to 1, so that means you are having s1. So that means we will go up to the term a1. So that means we will just have the term a1 with us. So this is a1. And according to this formula, we can put the value of n as 1. So that we would have 1 times p plus half, correct? Multiplied by 1 multiplied by 1 minus 1 multiplied by q, right? And 1 minus 1 is 0, so this terms is 0, so we are just having p as the answer, correct? So this is our the sum of first term. The sum of first term basically means we are just having the first term, so this gives us our first term as a1, correct? Now if we substitute n is equal to 2, what does it mean? It means Sn is equal to this thing. So that means when we put n is equal to 2, we are going up to the second term. So that means we would just have a1 plus a2 here. So S2 would be a1 plus a2. And in this formula, when we substitute n is equal to 2, we have 2p, right? Half as such. Then the value of n as 2, the value of n minus 1 as 2 minus 1, q as such, right? So this 2 and 2 cancels each other. We have 2p, right? And here we have 1q, correct? So this is what? This is a1 plus a2, right? Similarly, we can calculate for n is equal to 3. For n is equal to 3, our Sn, here we are going up to n is equal to 3. So we are going up to a3. So that means we would have a1 plus a2 plus a3 in the sum, correct? So here also we can put the value of n as equal to 3. So that we have 3p plus half 3 minus 1, that is 2q. This 2 and 2 cancels with each other. So we are having here the value as 3p, right, plus 3q. Here it should be 3. So we have 3p plus 3q as S3. Now we have S1, the sum of first term. So this is our first term actually. Now we wanted to determine our AP. So we require A1, we require A2, we require A3 and so on. So we have the value of A1, which is P, right? In order to determine A2, you see we have A1 plus A2 here and A1 here, correct? So from here you can see that your A1 is P, your A2, you can write A2 as A1 plus A2 minus A1, correct? Because this and this would cancel and you will just have A2. Okay, what is A1 plus A2? A1 plus A2 is your S2, correct? This is your S2. And what is A1? A1 is your S1. And you know the value of S2, it is 2p plus q. And the value of S1, that is p, correct? so that you have p plus q as the second term. So the common difference is calculated simply by subtracting the second term from the first term, right? So our second term is p plus q, the first term is p, so that their difference is q. So that means this is our common difference, and this is what we wanted to calculate here in this question. For the next question, they are saying the sum of n terms of two arithmetic progressions, they are given to be in the ratio 3n plus 8 and 7n plus 15, correct? So we need to find the ratio of their 12th terms. So that means if we suppose our first AP to be A is the first term, here D1 is the common difference. For the second AP, B is the first term and D2 is the common difference, correct? So for these AP, first AP would be A plus D1, A plus D2 D1 and so on. The second AP would be B plus D2, B plus 2 D2 and so on. So therefore the sum of, now we are given the sum of first n terms of each AP is given to be in this ratio. So that means the first of n terms of first AP divided by the sum of n terms of second AP is given by 3n plus 8 divided by 7n plus 15. And now we can substitute the formulas here for the sum, right? The formula for the sum of first n terms of the first AP, it would be n by 2, 2a, the first term of the first AP, right? Plus n minus 1 times d1, the common difference of the first AP. And similarly n by 2 here, 2b, b is the first term of the second AP, plus n minus 1 d2, which is the common difference of the second AP, which is equal to 3n plus 8 divided by 7n plus 15, correct? Now we can solve this n by 2 and this n by 2 cancels with each other. So we are left with 2a plus n minus 1 d1 and 2b plus n minus 1 times d2. Correct? This is equal to 3n plus 8 divided by 7n plus 15. So let's mark this as our equation number 1. Now in the question they are asking find the ratio of their 12th term. So that means what is the 12th term in this AP? It is a plus 11 d1, correct, which is a12. And what is the 12th term in the second AP? It is b12, which is b plus 11 d2, correct? This is the 12th term. So we need to find their ratio. So we have to find a12 upon b12. Their formulas are a plus 12 minus 1 d1, b plus 12 minus 1 d2. Right, so we solve them to have the value of the first of the upper term numerator as a plus 11 d1 and the denominator as b plus 11 d2. Right, so what we can do, we can, because this is a ratio, this is a fraction, we can multiply both the numerator and denominator by any number. So let's do it by 2. You will see in a moment why we are doing this thing. So if we multiply the numerator as well as the denominator by the number 2, we would have the ratio as 2a plus 22 d1 divided by 2b plus 22 d2. Let's mark this as equation number 2, right? So we wanted to calculate what is the value of this thing using our equation number 1. Now you see, if in this equation, if we substitute n is equal to 23, now what do we have? We would have 2a plus 23 minus 1, which is 22 times of d1 divided by 2b plus 23 minus 1, which is 22 d2, right? So you see this term is exactly equal to this term which is written in equation 2. So that means that is why we have multiplied both the numerator and denominator by 2 and converted it into this form, so that we may use equation number 1. So the value of this thing from equation number 1, it would be the value of this same thing when the value of n is 23. So we would just substitute the values here. So this is equal to 3 into 23. So 3n plus 8 would become 3 into 23 plus 8, and 7n plus 15 becomes 7 into 23 plus 15. So the upper term is 77, the lower term, the denominator term is 176. So you could reduce it by dividing by 11 on both sides. So you have 7 by 16 here. So that your answer, the ratio of the 12th terms of both the AP, that is 7 by 16. And this is what we wanted to calculate here in this question. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.